So, hello everyone, welcome back to sisyaclass. I hope you had an amazing paper today and you are really excited for this paper discussion session. So, don't worry if you're worried about whether your answers are right or not. Me, Ahmed Sir and Nidhi Ma'am here are ready to help you out. So, we hope you are ready for the session. We'll get started. Yes? So, let's start with the first question. You must be knowing the paper pattern and the number of questions and marks allotted. So we will not waste time here. We'll start with the first question. So this is one of the easiest paper that I have seen. So I hope you were able to solve this question. So the question was, predict and write why preparation of lime water is considered an exothermic reaction. So first we need to write what is an exothermic reaction. So exothermic reaction is reaction in which heat is evolved. Yes, exothermic reaction is a chemical reaction in which heat is evolved. Now we have to write the preparation of lime water. We have to write the chemical reaction of it. How lime water is formed? When calcium oxide, yes, we also call it quicklime, is mixed with water. Water is H2O. Yes, it forms calcium hydroxide, which is also called slate lime. And in this reaction, a lot of heat is evolved. And you can see a lot of steam as well. So since in this reaction a lot of heat is evolved, it is called an exothermic reaction. I hope this is clear to you. Yes, so we'll move on to the next question. Yes, acidic nature of a substance is due to the formation of dash ions in solution. So the answer is hydrogen. The answer is hydrogen ions in the solution. How do we write hydrogen ions? H plus. Hydrogen ions is the identity. The amount of hydrogen ions shows how much acidic the substance is. So this is the answer. Hydrogen ions is the answer. I hope this is clear. We'll move on. Okay, so the third question is, observe the following table. They have given substances and they have given the pH value. Okay, pH value in the above table, which is the strong acid. Yes, so first let's understand what is the pH value. We all know pH means power of hydrogen. We just now discussed that hydrogen ions are the characteristics for the acidic nature. Now this power of hydrogen in the acid gives its acidity or basicity. So first we'll discuss, we understood pH is power of hydrogen. Then there is a pH value scale, pH scale that we have. Yes, so what is the pH scale? In the pH scale, we started with 0 and it is all the way till 14. Yes, and the center 0 to 14 is 7. 0 to 7 is our acidic range. We have acids here. And from 7 to 14, we have bases. Yes, these are the basic range of the pH. Yes, and the initial 0 to 3 you can say. Yes, 0 to 3 is the range of strong acids. 3 to 7 is the range of weak acids. Then 7 to 10 is the range of weak bases. And 10 to 14 is the range of strong bases. So understand that the extremes of the pH scale are strong acid, strong base, and near to this 7 is what? Are neutral. This is neutral, right? So near to the neutral are weak acid and weak bases. Okay, so look at the values. Lemon juice 2.2, blood 7.4, and milk of magnesia 10. So what do you think? 2.2 falls in the range of strong acids, right? 2.2 falls under 0 to 3. So lemon juice is a strong acid. Blood is little very little basic in nature. Okay, it is more or less near to the neutral, and 10 comes here. Okay, at the edge of strong base. Okay, it's considered weak itself because it's on the border. Okay, let's move on to the next question. I hope this is clear. Which is the most ductile metal in nature? Okay, so the answer is gold. What is meant by ductile? Ductility. This is a property of metals. What is the property? That the ability of the metals or a substance, ability to be drawn into thin wires. This is the property of metals, that we can make thin wires out of it, and the most ductile metal is gold. So gold is the answer. Okay, I hope this much is clear. Let's move on. Write any one use of vinegar. Okay, so vinegar mostly we use in cooking, so you can write that vinegar is used in cooking. Okay, simple. We make a lot of Chinese food. I am sure a lot of you must be liking Chinese food. I like it. So in that we use vinegar for the making of it. Okay, it's a very simple question. I hope this is clear. We can move on. Yes, so I'll hand it over to Ahmed Sir right now.
Thank you so much, Rutika. Here's the physics part that we are starting with right now. So question number 6, we have the human eye forms the image on an of an object at where. Okay, so let us try to have a quick revision of what actually it is. So if this is the human eye, and let's say that this is the cornea, right? Okay, when light passes through it, okay, of any object, it gets accumulated at this point, and this point is actually considered as a screen of the eye, which is also considered as the retina. Okay, so basically the image that we create of any object inside the eye actually falls inside the or on the retina, and therefore the correct answer over here will be retina. Retina is the correct answer. Okay, so if you have answered this, so you have scored the marks for it. Moving ahead. Now the next thing is draw the symbol of an ammeter. Now this is a question from electricity chapter, okay, and it's one of the most easiest symbol to create. Okay, very easy. The symbol for ammeter is something like this. First you will start with a circle, and then you will write A. So A over here says that this device that you're connected in the circuit is an ammeter. Okay, followed by you'll have two wires connected. One wire will be connected to the positive terminal and the other one will be to the negative terminal. If you have done this much, it means that you have answered it correctly. Okay, however, you can add the directions of the current also, showing that the current is moving from the positive terminal all the way up to negative terminal. So this is the only answer for this question. Super easy. Okay, fine. This is how the ammeter can be created. Moving ahead. Then the next question is, what is the commercial unit of electric power? Okay, one of, again, most easy question. So if we talk about power, so we have the unit kilowatt hour. The commercial unit of power is kilowatt hour. And if you look at the formula, the commercial unit, if I say commercial unit is equal to what is the power which is consumed, multiplied by the time it is consumed. Okay, now the catch over here is that usually if we talk about SI unit, the SI unit of power is actually watt. Okay, and the SI unit of time is actually seconds. But because these units are very small, to do the calculation for commercial purpose, what we do is we use another unit. Okay, so instead of using watt, what we will be using is we'll use kilowatt, and for time, instead of using seconds, we will be using hour, and therefore the commercial unit becomes what? Kilowatt hour. This is from this formula. All right, so the answer for this is kilowatt hour. If you have written this much, it means that you have scored for this question. Okay, I believe this is clear to all of you. Moving ahead. Okay, so next question is from chemistry, and I would like Rutika to take over now.
Yes, thank you so much, sir. The question is about class of compounds and formula of functional group. So the functional group is basically the identity of a compound. Okay, from the functional group we can identify what type of or what class of compound it is. So for alcohol the identity is OH. Okay, alcohol is identified by the OH group, OH functional group. Okay, and the COOH, or else you can write it like this, the same thing, you can write it like this. This is carboxylic acid. This is carboxylic acid. I hope this is clear to you. Yes, let's move on to the next question. Yes, this is the physics question, so Ahmed Sir will be solving it.
Okay. Now this is one of the most interesting question that I've seen in this question, because this question's answer is a question itself. So the question is asking you to create some question. Okay, not the answer actually, right? So one of the most interesting question that I've seen in this question paper. Okay. Now the question is saying that you are supposed to make two questions that will help you to understand the concept of refraction. Okay, now let's try to understand this. We are not supposed to write the answer but just the question, and we are supposed to frame two questions for it. Okay, so I'll create the first question first. Okay, and this can be around any topic of refraction which a person can ask to understand refraction even better. Okay, so let me ask you first question. Okay, so we'll say why does the speed of light changes in different medium? And if you know that the answer will be because of optical density. With changing optical density, the speed of light will change, and changing speed of light will make it bend. However, we don't need to write the answer because this question has asked us to only frame questions. Okay, moving on to the next question. Okay, second question can be anything. I'll say what is refractive index. Okay, now you can assume this, that these are questions that a student might get to understand what is the concept of refraction. So from here the student will understand what is refractive index, and from here the student will understand that why actually bending of light takes place. If you have written these two questions, you will get scores. However, if you write any other questions related to the refraction topic, that also will give you the scores also. Okay, so the questions that you can frame is many. I just gave you two examples. Okay, now the next thing is predict and write why the tungsten is used as a filament in electric lamp. Again, this is a topic from electricity chapter. Let's try to make a bulb first. Okay, so let's say that if we have a bulb, this is the base of the bulb. Okay, and we have the covering, and here we have the filament, right? This filament is actually made up of tungsten. Okay, now there are two reasons that we have used this material to be very specific. Okay, now those two reasons for choosing tungsten in this case is, first one, that it has very high melting point. Okay, it has very high melting point. Okay, so this is point number one. So why do we need high melting point? Because despite being in very extreme temperature, it will not melt. If that material melts, this will break down the circuit and the circuit will no longer work, right? Which we don't want. We want continuous flow of electrons, continuous flow of charge, right? And therefore tungsten is used in this case because it has high melting point. Okay, second thing is that it has high resistance. Okay, high resistance. Now why do we need high resistance? We need high resistance because we want the light or the bulb to emit light very soon. Okay, if the resistance is low, then we'll need some time for the bulb to glow after supplying power to it, right? But in our case, what happens is the moment you switch on the light starts glowing, right? Why? Because this resistance will create tremendous amount of heat energy, and that heat energy will be emitted in the form of light. Okay, so these two are the main reason why tungsten filament is used in electrical lamp. Okay, so if this is something that you have written as the answer, then you might have got the score for it. Moving ahead, then we are moving to section number 3. Okay, so the weightage of these questions will be much more, and accordingly we'll need to write the answer. Okay, your answer should always be according to the marks that you will be getting in that question. Okay, now in this case, the very first question is draw the ray diagram of image formed by object placed in front of concave. Okay, so we have concave mirror over here and two different conditions at C and at P and F. Okay, so let me move to the next slide, and here I will be solving it. Okay, so we have concave mirror. So I'll make two concave mirror. This is for answer A and this is for answer B. Okay, and you might have used some proper instruments to create your diagrams. Here I'll be doing free-handedly. Okay, and make sure that you will show this coating notation so that it is fixed that this is a concave, mirror. Okay, focus, and then we have center of curvature, then we have focus, and then we have pole. The lines will be created. So this is the basic ray diagram for concave mirror. Okay, moving ahead, here we'll be creating the lines for the ray diagrams. Okay, so case 1 was where the object was on C. So we'll create the object on C, and from here we'll label it A and B, and from here we'll be creating two rays. Okay, these rays can be created using any of the two rules from the 3 rules that we have learned. Okay, I'll use rule number 1. Rule number 1 is if it is parallel to principal axis, it will go through F after reflection. Okay, this is rule number 1. Then we'll use rule number 2. Rule number 2 is if it passes through S after reflection, it will go to C. Okay, now because I have not used proper instruments and measurements, I would not get correct intersection, but ideally your intersection should come over here, your image will fall over here, and you will get A and B dash this way. If you want to write the properties of the image here, it's not asked, but still I'm telling you, then the properties will be that the image is inverted because it is upside down flipped. The second thing is that it is a real image, because for image which is formed in case of mirror, if it is formed in the left side, then we have a real image. Then the magnification will be same as object. The size of the object and the image will be the same. So I'll say same as object. And then the fourth one is where it will be placed. So we will say on C. Okay. So if your object is on C, your image will also be on C. Okay. Now, the second question is, if you see, it is asking between P and F. Okay, so if you keep your object between P and F, this is A and this is B, you will use rule number 1. Rule number 1 is parallel to principal axis. After reflection, it will pass through the point F. Okay, and then rule 2 is not applicable, because if you create rule 2, the line will keep on going down, but it will never intersect, right? And therefore we will not use rule number 2, but we can use rule number 3. Rule number 3 says that if a light passes through C, it will after reflection it will bounce back through the same path. Okay, again you will not see intersection happening over here. However, these two lines are non-parallel lines, and non-parallel lines meet somewhere or the others after extension. Okay, so if I extend in this side, it will keep on increasing the distance between these two lines. However, what we can do is we can extend in this side, and we'll see that where the intersection will happen. And let's say that the intersection happened over here, so we can form an image over here like this, saying that this is A dash and this is B dash. Okay, and then you can also extend the principal axis also like this way. Okay, so this is the diagram for the second question. Now if you want to write the properties of the image, again it's not asked, but I'm still telling you. Okay, so it is erect because it is in the same orientation as the object is. The second thing is it is virtual because this image is falling behind the mirror or inside the mirror, I would say. Then the third one is that it is magnified because its size has increased as compared to its object. And then the position will be behind the mirror. It will be behind the mirror. Okay, so this is the correct answer for this question. Okay, now however, if you would have done this, then we have the next question also. It is draw the diagram which shows that acid solution in water conducts electricity. Okay, now because this question is from chemistry, Rutika will be taking ahead.
Thank you, sir. So let's solve this. So the question is 12th B question. Draw the diagram which shows that acid solution in water conducts electricity. So I'll move to the next page. One second. Just a minute. Yes, 1 second. So we have to make a circuit basically which conducts electricity but using the liquid. Yes, so in a circuit we always have a battery. This is our battery. Then our circuit will always have a bulb. Yeah, it will have a bulb and it will have a switch. Yes, what is this? This is our battery. This is our switch, this is our bulb. This is our bulb and this is our switch. Yes, and we have to make a circuit out of it with conducting liquid. So we'll connect iron nails here. Yes, and we'll place these iron nails will act as electrodes and we will place this in a conducting liquid, like we are considering a dilute sulfuric acid, and we'll make this cork here. Yes, this will be our rubber cork and there will be liquid in it. Yes, and now we'll name it. These are our iron nails which are acting as electrodes. This is our dilute sulfuric acid. Yes, and this is our rubber cork, right? So now this becomes our diagram in which the conducting liquid or the liquid is conducting electricity. Now you tell me what will happen in this bulb. I have already said that this is an acid. First of all, we know that acids are conducting liquids and we are making a circuit in which the liquid is going to conduct electricity. So the bulb will glow or not? Yes, the bulb will glow. So we can show the glowing bulb in this way as well. Okay, so this is the answer. Let's move on to the next question. Yes, question number 13, give 2 important uses of each of the following. The first is bleaching powder. Okay, so 1 second. The first answer we'll write for bleaching powder. Bleaching powder is nothing but our calcium oxychloride. Okay, so the first use will be in bleaching cotton, linen, in textile industry. There are a lot of uses, you can write any 2. Bleaching cotton and linen in textile industry, in the textile industry. Okay, and the second you can write like it is used to kill germs in the water and make it safe for drinking. Kill germs in the water, it is used to kill germs in the water. Okay, or else it is used in the bleaching of wood pulp as well, or the bleaching or the laundry services that we use in our daily life. There also they use bleaching powder to bleach our clothes. Okay, I hope this is clear. Then let me solve the next one. The second one is baking soda. Okay, I'm sorry, 1 second. So baking soda is nothing but sodium hydrogen carbonate. Okay, baking soda is sodium hydrogen carbonate, and the first use is, you can write, it is used in soda acid extinguishers, fire extinguishers. There are a lot of types of fire extinguishers. So baking soda is used in soda acid fire extinguishers. also, it is a base, it is basic in nature, so it is also used as an ingredient in antacids. Ingredient in antacids, as it is basic or alkaline in nature. You can call it alkaline, basic, or basic in nature. So it neutralizes. What does an antacid do? The antacid neutralizes the excess acid in your stomach. Okay, because baking soda is basic in nature, it can neutralize the excess acid in your stomach. Okay, I hope this is clear. Let's move on to the next question. Yeah, okay, this is the physics part.
Hello once again. So here we are gonna solve this question. Okay, it's all about refractive index. And before we solve this question, we'll quickly understand what is the idea of refractive index. Okay, so the idea of refractive index is that higher the refractive index is, the higher the refractive index is, I would say the higher optical density will become. Okay, optical density of a medium is related to the refractive index, and both are like I would say proportional. So if the optical density increases, the refractive index will also increase. Okay, and likewise if it goes down, then this will also go down. Okay, I believe this is clear, right? And with this it becomes very easy to solve this question. Okay, let's see this question. Here we have a table which says that which lists a lot of material followed with its refractive index, and here we have some questions that we are supposed to answer based on that table. Okay, now in this table, if you see in this question, you see we have which medium has highest optical density. So optical density is, if it is high, then the refractive index should also be high. So the material which has the highest refractive index will have the highest optical density. In that case, that's going to be diamond, and therefore for first it's going to be diamond. That's how simple it is. Okay, again, in which medium speed of light is minimum. So now we'll establish a relationship between the speed of light and the refractive index also. Okay, now if the optical density is high, then refractive index will also be high, which means that speed of light will be low. Okay, because the higher the density, the slower the light will be in that dense material. Okay, now therefore we can say the same thing in the opposite way also. The lower the optical density, the lower will be the refractive index, and therefore the higher the speed of light will be. Now using this relationship, we can answer the next question also. Okay, in which medium speed of light is minimum. If we want to find the minimum speed of light, we'll try to find out the maximum refractive index, and the maximum refractive index over here will be again diamond. So second answer is again diamond. Okay, now if you are using this, your question will be super easy. Okay, in which medium the light travels faster. Now higher speed means lower density, and lower density means low refractive index. So the lowest refractive index over here is actually air, and therefore answer number 3 is gonna be air. Okay, and then fourth question is which medium has least optical density. Least optical density means least refractive index, and least refractive index is again air, so the answer is air. So super easy. Very, if you are clear with this thing, then answering this question will be super easy. So the answer is diamond, air. Okay, I believe this is easy and clear to understand to all of you. Okay, moving ahead to the next part. Okay, now here we have a next question. This is section number 4, and we'll be solving this question now. Okay, in question number 15, we have the first question as explain what is myopia and how you can rectify it. Okay, so first of all, we'll say that what myopia is. So point number 1 will be that it is nearsightedness. Now what do you mean by nearsightedness? Nearsightedness means a person who is myopian will be able to see only things which is close to him but not far away. Okay, which means that his far point gets disrupted but his near point of vision is actually fine. Okay, so that is called as myopia. Okay, now you can also go ahead and add the causes of it. Okay, what are the causes? So second point you can write about causes. Okay, now talking about causes, the first point can be elongation of the eyeball, because the eyeball is elongated, the retina, the position of the retina gets shifted ahead, and therefore the image which is formed by the cornea and the lens is not actually falling on the retina, and therefore it is being formed right before the retina, and therefore we'll see blurry images. Okay, so the first point is elongation of eyeball, and this is usually a birth defect. Okay, second thing is that too much bulging of your eye lens, so your eye lens will be too much bulged this way. Okay, and this will make the light bend too much, and the image will be formed way ahead than the retina. Okay, so we'll say bulging of lens. Okay, so we are done with the first part of the question. Explain what is myopia. Okay, now the second is how can you rectify it. Okay, now this can be explained by creating or making some diagrams. Okay, so if I create the diagram for a myopian eye, we can create a circle showing the cornea and then draw two rays coming towards the cornea, and then if once they converge to a point which is before retina. The convergence was expected to happen in the retina or on the retina, but it happened before it. Okay, so this is a defective eyesight. Okay, I'll say defective eyesight. Okay, so how would you correct it? Okay, how would you correct it? Again, you can create the same diagram, but this time you will put a concave lens over here. Okay, a concave lens is a lens which has a power of negative. So if you have a spectacle which has a negative number, you're basically using concave lens, and that means that your myopian eye is being corrected. Okay, now what happens is this concave lens is actually a diverging lens, and divergence means what? It will move away the rays. So the rays which were being converged in a point, this concave lens will actually diverge it to some extent, that after convergence in the eye lens it will fall inside the retina. So first the rays will come over here. The first thing which will happen is divergence, and after divergence that it will get converged to this point, and therefore we'll be able to see it. So to rectify this defect, we will be using a lens of correct power of concave type. Okay, a correct power of concave lens will be used to rectify it. So if you have covered all of these points in your answer, then you would get good scores. Okay, moving ahead to the next. If you might have not solved this, but you have solved this one. Okay, so we can we'll answer this part too. So we have the first thing is electric current. Okay, so I'll quickly cover that point. Electric current. What is electric current? Very simple definition. Okay, electric current, also symbolized as I, is considered as rate of flow of current. Okay, rate of flow of current, and the formula is I is equal to Q by T. This is the formula, and the SI unit will be ampere, also abbreviated as A. Okay, abbreviated as A. Let me write this A properly. Okay, so this is the first definition. Second, moving ahead. Now the second question was for potential difference. Okay, so we have PD. Okay, sometimes also written as voltage. Okay, it is the amount of work done to carry unit charge Q from a point to another. Okay, the amount of work done to carry unit charge Q from a point to another. You can also write W for work done, and you will get the formula V is equal to W by Q. Okay, this is the formula, and its SI unit will be volt and abbreviated as capital P. Okay, then we have third question. Okay, moving into the third one, electric resistance. Now electric resistance, or we can simply say as resistance, we have R, and we'll say that we'll say the force resistance, yeah, we'll say force which opposes the flow of charge. Okay, the formula for R is V by I, and the SI unit is ohm, symbolized with the Greek letter omega. Okay, fourth one. Then we have electric power. Okay, moving ahead, we have electric power. The symbol is capital P, and we'll say the electric work done to carry unit charge. Okay, the formula for P is gonna be V into I. The SI unit is gonna be watt, which is coming from James Watt, who was the person who had contributed a lot of in power theory. And then we have the symbol of watt as W. So these are the definitions and the formulas followed with the SI unit for all the definitions that you had. Okay, moving ahead, we have the next question from chemistry, and I would really like to invite Nidhi Ma'am, our expert in chemistry, to solve this question. Over to you, ma'am.
Okay. Alright, so we have to balance this equation. So we are going to study the rules also along with it. Okay, let's start with the first part. We have to write the chemical formula first, and then we have to balance it. Okay, so we have calcium hydroxide plus CO2 giving us calcium carbonate plus water. So we have to balance this equation. See, the first thing you will do, see the different types of atoms which are present in your reaction and how many number of such atoms are present on the reactant and the product side. Just see that. If they match, then your equation is already balanced. If they don't match, then we will see the next part in which we will balance it. So as you can see in this equation, the number of calcium atoms on the reactant product side, they are same. Okay, one calcium atom here, one calcium atom here. Okay, great. What about oxygen atoms? I can see 4 oxygen atoms on this side. I can clearly see 4 oxygen atoms on this side also. What about hydrogen? 2 hydrogen atoms here, 2 hydrogen atoms here. And finally carbon. Carbon, only 1 atom is present on both reactant and product side. So the equation is already balanced. You don't have to do anything. The number of atoms on both sides must be same. So all the atoms are same on reactant and the product side. Just leave the equation like this. You have written the chemical formula and the equation is already balanced. Now let's balance the second part. So see the question. Zinc, silver nitrate, AgNO3, zinc nitrate and silver. Now you can see this equation is not balanced. Now we will try to balance it. Let's see the steps involved. You don't have to write the steps. This is just for your understanding that you already know. You just have to balance it using those steps. Okay, see. We have zinc plus silver nitrate giving us zinc nitrate plus silver. Now definitely the number of atoms are not matching on the reactant in the product side. So from where should we start? We have so many different types of compounds mentioned in the chemical reaction. So which compound should we choose? From where we can start the balancing part. So you have to choose one such compound which has maximum number of atoms present in it. One simple way to remember it. Okay, so we will choose that compound which has maximum number of atoms. Now within that compound, with those number of atoms, which atom should we choose? Again, choose that atom which has maximum number present in the compound. So first thing, choose the compound with maximum number of atoms, then choose the atom which has maximum number present in that compound. Not very confusing. Okay, so we have zinc, silver nitrate. zinc nitrate. I can clearly see maximum number of atoms are present in this zinc nitrate. So we will start the balancing with this compound. Okay, so how should we go ahead? So I can see I have only one nitrogen atom here and I have 3 oxygen atoms here. But on this side we have the double amount. I have 2 nitrogen atoms and 6 oxygen atoms. So start with the balancing of these nitrogen and oxygen itself, or the nitrate itself, because that would be even more simpler. Okay, so you can clearly write here 2. So now you can see the nitrogen atoms are balanced. 2 nitrogen atoms on the reactant and the product side and 6 oxygen atoms on the reactant and product side. But now the silver is off. I have 2 silver atoms on the reactant side. I have only 1 silver atom on the product side. That is simple. Just place a 2 here. Now you can clearly see the equation is very much balanced. All the atoms are same on the reactant and the product side. These are the steps you have to follow. Now try to see the next one. It is even more simpler. Okay, see the next one. Barium, okay, this one. Aluminium, copper chloride, aluminium chloride, and finally copper. Again, we can see the number of atoms are not matching on the reactant and the product side. Okay, so which particular atom we can see is not balanced? I can see I have 2 chlorine atoms here and I have 3 chlorine atoms here. So we will start with the chlorine. Okay, so how should we balance it? Let me write this here only. We have enough space so that you can see the equation also. AlCl3. We are using the same method, okay? We are not doing anything new. So we will start with the compound with the maximum number of atoms, AlCl3. Within that compound also, we are going to find chlorine, which has 3 atoms present. We will start with the balancing of chlorine, okay? So I can place a 2 here, I can place a 3 here. So the chlorine atoms are now balanced on both sides. I have 6 chlorine atoms on reactant as well as product side. Now please see any other atom which we have now increased the number that was not present in the beginning. So chlorine is done, but I can see now we have increased the number of aluminium atoms. So please balance that also. Just place a 2 here. Now what about copper? Copper is also not balanced, but copper is present in isolation, so we don't have to worry too much about copper. We can simply place a 3 here. So please see, now this equation is balanced. So we started with aluminium chloride. Why? Because that was the compound with maximum number of atoms. Then within aluminium chloride, we chose chlorine. Once we have balanced chlorine, we moved on to the other atoms which are present in your chemical reaction. Okay, see the last one. This is barium chloride. This is potassium sulfate. Barium sulfate. And this is potassium chloride. Okay. Again, this equation is not balanced. Okay. So from where should we start? Same thing. Choose a compound which has maximum number of atoms, as I am repeating it again and again. So out of everything that is written here, I can see this one has maximum number of atoms, right? So we will start with the balancing of potassium here. Okay, I have 2 potassium atoms here. I need 2 more here. Great. What about chlorine now? See, chlorine is already balanced now. You don't have to do anything. I have 2 chlorine atoms here. I have 2 chlorine atoms here. Now finally, once you are done with it, okay, don't just leave it then and there. Try to verify. Try to see whether you have balanced all the atoms or not. Don't just focus on that compound that we have started with. Please focus on the other atoms also. Cross verify in the end also that whether all the atoms are matching or not. Okay, so everything is balanced now. So that is how you can balance the chemical equation, but you should know the formula also. Okay. Now the next question, Rutika Ma'am will solve.
Yes. So let's move on to the OR part of this question. Let me clear this for you first. Yes. So the or part of the 16th question is explain the mechanism of the cleaning action of soap. This is a very interesting concept and we'll see how we can write the answer for it. Okay. Just a minute. Yeah. So we are writing about the, one second, cleaning action of soap. Yes. So for understanding the cleaning action of soap, we should understand how the soap molecules look. So I am going to show you how a soap molecule looks. I am very sure you know this, but still, if you draw diagrams in your exam, it would be really helpful for the examiner. Also, it makes it easier for them to understand that yes, this child knows the answer. Okay. So the soap molecules has two different parts with different properties. Okay. So this is somewhat what a soap molecule looks like. The initial part, like it is usually sodium ion. Okay, is the ionic part. Ionic part or ionic end, you can say, of the molecule. Ionic end, and this ionic end is hydrophilic in nature. Hydrophilic means liking towards water. This part of the molecule likes water. It will interact with water, and the rest, the remaining part of the molecule is, you can call it the hydrocarbon part. This is the hydrocarbon end or hydrocarbon part of the soap molecule, and it is a hydrophobic. Phobic in the sense it does not like water, it does not like interacting with water, it will not interact with water. Hydrophobic end, you can call it. I hope this this diagram is clear to you. Soap molecule has two ends. One is ionic end, that is hydrophilic in nature, and the remaining part of the soap molecule is the hydrocarbon end, which is hydrophobic. It does not like interacting with water. So one part is going to interact with water, the other part is not going to interact with water. So let's see how this functions. Yes. Now if we have water and we have soap in it, okay, so the ionic ends of the soap are going to interact with water. That means they are going to have a liking towards it, they are interacting with it, and the end part, the hydrocarbon part or the hydrophobic part, is going to try to avoid or repel water. So this structure is going to occur, you will be able to see, not see, but this is what is going to form inside the water with soap solution. This structure is called a micelle. Basically, and obviously not just one, but a lot of micelle formation happens in the water, soap water, you can say. Yes. Now the dirt particle, we have basically the function of soap is to remove the dirt, grease, oil from the clothes, right? So how will it do that? Because this hydrocarbon part is not interacting with the water, but it interacts with the dirt, with the oil, with the grease. Okay, so this end, the hydrocarbon or hydrophobic end of the soap molecule, interacts with the oil, grease and dirt, and hence since it interacts with it, it will trap the dirt particle. You can say this is the dirt particle in this. Okay, this is how the dirt or the oil, the grease gets trapped between the soap molecules. Okay, and when you wash it off, okay, when you rinse it off, all this dirt, oil and grease comes out of the water. Okay, I hope you understood the cleaning action of soaps. With the help of this diagram, you can explain it better and you can write in your words as well what I just said. I hope this is clear to you. Moving on to the next question. Yes.
Thank you, Rutika. Alright, so now we'll be moving to question number 17. Okay, this question is from physics and it says that explain the experimental procedure to show that the current carrying conductor placed in a magnetic field experiences force on it. Okay, so we'll need to basically create an aperture, and then we'll need to explain that how this aperture will actually work. And the second highlight of this question is Fleming's right hand rule. Okay, so if you're explaining these two things, that will cover the entire answer. Okay, so we'll first of all create the aperture. Okay, so first of all we'll have a stand. Okay, we'll create this stand like this. Okay, and here we'll have a suspended magnet. Okay, let's say that here we have a suspended horseshoe magnet. Okay, something like this. Let's assume that this is the north pole and this is the south pole of the magnet. Okay, and follow to that we'll have a rod or any object. Okay, and this rod will actually have insulated wires wrapped around this rod. Okay, and then here we'll have the wires connected to a power source and a switch. Okay, this will be the positive end and this will be the negative end, so the current will be moving in this direction. Okay, now this is the apparatus that we will be creating to understand this experiment. Okay, now moving ahead to that, we'll also need to know that in which direction is the magnetic field moving. And if you remember the properties of magnetic field, it will always move from northern pole to the southern pole. Okay, so from northern pole it will come towards the southern pole. This is the direction of magnetic fields. Okay, so now we have two different directions. One is the direction of the magnetic field, which is from north pole to south pole, and the other direction is of the electric current, which is in this direction. Okay, so what we will do is basically, if you see, this is the direction of magnetic field and this is the direction of current and magnetic field. Now the thing that I am supposed to find out is the direction of the force acted upon that object. Okay, now this will be explained very clearly by Fleming's right hand rule. Okay, so Fleming's right hand rule says that if you take the first three fingers, the thumb and the first two fingers, and make it perpendicular, mutually perpendicular with each other, every finger over here will represent one factor in this apparatus. Okay, for example, the thumb will represent the direction in which the force will be applied. The first finger will represent the direction in which the magnetic field is moving, and the middle finger will actually represent the current direction. Okay, now if we place these fingers this way, okay, and I say that the magnetic field is downward, so I'll take my first finger downwards. Okay, so this is how it is, and then I'll take my current this way, which means that my thumb is pointing outside the screen. This shows that the rod, after being suspended between the ends of the horseshoe magnet, it will come towards me. However, if I reverse the polarity of this battery, what will happen is, then the current direction will be opposite, and if I turn on the circuit, then what will happen is the rod will move away from me. Okay, so this is how we can use the Fleming's right hand rule to determine the direction in which the force will be acted, and also determine in which direction this rod will be moved once the circuit is on and when it is suspended between a magnetic field. Okay, I believe this is clear. Using this diagram itself, you will explain the entire concept. So you just need to write it in a story form or in bullet form, that so and so things will happen if you conduct this experiment. Okay, so that is everything. Let's try to read the question and see if I am missing anything. Explain the experimental procedure to show that the current carrying conductor placed in a magnetic field process. Yeah, we have covered everything. Okay, then in the OR section, it is coming from chemistry, so we will call Nidhi Ma'am to cover this question.
Okay, so one last question. We have to explain the experimental procedure to investigate the conditions under which iron rusts. So for the rusting of iron, you need two things: moisture as well as air. If you have moisture only, iron will not rust. If you have air only, iron will not rust. So we are trying to show that with the help of our experimental demonstration. Let's see. Okay, so what are the things we require? We need 3 test tubes, three iron nails, obviously, we need distilled water, Okay. Right. So we want distilled water. Give me a second. Yes. So we want 3 test tubes. Three test tubes, 3 iron nails, distilled water, boiled distilled water, some oil. Boiled distilled water, paraffin wax will work, or you can take oil. Okay, so what should we do next? In those 3 separate test tubes, in the first test tube you will take 1 iron nail and you will add distilled water to it. Okay, so distilled water is present, iron nail is present, and we are not adding anything extra, so both air and moisture will come into contact with that iron nail in test tube A. What should we do for test tube B? You will take boiled distilled water here, so all the air is removed from it by boiling, and you will cover that test tube. After you have added the boiled distilled water, you will add some paraffin wax over it. What is the purpose of adding paraffin wax or oil? It will not allow air to come into contact with your boiled distilled water. So in test tube B, you only have added boiled distilled water and oil, so only water is present, there is no air there, so rusting will not occur. What should we do for test tube C? There we will take anhydrous calcium chloride. What is the purpose of taking anhydrous calcium chloride? It will remove all the moisture, so there will be air present in test tube C, only air. So in test tube A, both air and moisture, rusting of iron will occur. In test tube B, boiled distilled water plus oil, only water is present, no contact with air, rusting will not occur. In test tube C, we have the anhydrous calcium chloride and our iron nail, so there is no water present and all the moisture is absorbed by calcium chloride, so there is only air present in test tube C, no rusting will occur there also. So what is the conclusion that we can draw from here? That in order to see the rusting of iron, both air and moisture are necessary. It will not occur in the presence of air only, it will not occur in the presence of moisture only. Both air and moisture are necessary for rusting to occur. So that was your entire experiment. That is how you should have explained in your examination. You can draw one diagram also if you want, otherwise the explanation enough is you will get marks, good marks for that as well. Okay, but try to draw diagrams wherever you can draw them. Okay, so that is all for today. I think we have solved all the questions. I hope you liked it. Yes, let me.
Yes, thank you so much, Nidhi Ma'am, and thank you, Ahmed Sir. So we have reached to the end of our session. I hope you enjoyed with all us, Ahmed Sir, Nidhi Ma'am, and myself, and you got clear explanation for your paper. Yes, so if you enjoyed today's class, please join sisyaclass, a 7-day booster program for just ₹29. The link is in the description, and follow us for more such content. And if you like us, like, share, subscribe, and we'll see you again. Bye bye.
Bye.
Take care.